Okay, stats. We are starting chapter 3 now, and this first section is called Measures of Center. And this is the section on mean, median, mode, all that good stuff. Mean, median, mode, range, all that stuff. So that's kind of fun. Like you're going back to like 4th grade math. But we do get a little bit deeper into this. So don't think some of it is quite that easy, yes. But we talk a little bit more about like what it means to be a resistant value. So we'll get to that. But just as a review, I know that you guys mostly know what this is, but I know that Mary might have other terms for this. So on her behalf, I'm going to talk about mean. We'll go median. And we'll go mode. And we'll go range. Okay. And then there's another one that we're going to talk about that we usually don't in like 4th grade math, which is called the mid-range. And so we'll discuss what that is. But anyway, mean is the average of values. I'll go average. Okay. And the average, I don't know if that term sounds familiar to Mary, but average is like adding up all the scores and then dividing by the number of numbers that you have. Okay. So that's what the mean or the average is. Okay. Median is the middle number. Okay. Out of a data set. And then it has to be in order. Okay. Mode is the number that occurs the most. So it's the most often used number. Okay. Now, if you have a data value that, like, let's say I have a data set that's full of all my grades, and I have 2 grades that are a 95 and 2 grades that are a 92, both of them would be considered modes. All right. Now, one thing that you want to make sure and remember is that you never put 0 as a mode if you don't have a mode, right? If there's no mode, you put no mode, because 0 could be a mode. Right? 0 could be a number that's repeating the most, right? So don't put 0 down unless 0 is a number in your data set that occurs the most, right? You can either do this if there's no mode or just put no mode. Okay. Ooh, that M had 3 little humps on it. Anyway, so mode is the number that occurs the most. And then range is the highest number. I'll say the biggest number. Biggest number minus the smallest number. It's like how far does your data span? Like how far across does your data span? And that's the range. Okay, now while we're on this, we're going to talk about resistance. Okay, so when we talk about resistance, we're talking about how outliers or extreme values affect these things. So is it resistant or is it not resistant? A statistic is resistance if the presence of extreme values does not cause it to change very much. It's considered to be a resistant value. Okay. So just for example, let's say I have a 95, a 96, another 96, a 97, and a 99 in the grade book, right? That's my data set, okay? The average, I'm going to take all of those, add together, and divide by 5, right? So it's going to be somewhere in like the 97 range, probably. Something like 96, 97 range, whatever. That's what my average is. But let's say I throw a 0 in there, right? And that's considered, in my case, an extreme value, right? Like that's extremely low in comparison to the other ones that I have. Is that going to pull the mean way down? Is that going to pull the average down? Well, some of you guys, if you've had that happen before, if I've thrown a 0 in the grade book because you haven't turned an assignment in, you'll know, yep, my grade plops down to like a 40% or something, or 60%, okay? So the mean is not resistant to outliers, okay? He will change a lot. Will change lots if I put an outlier in there, okay? That's the same way if it was like a high end. So if I'm normally getting 80s and whatever, and I all of a sudden get 100, okay, it's going to pull my average way up, right? Maybe not as much as a 0 would if I'm getting 90s, but it's the same way if you have like a high end outlier as well, okay? Your mean is going to change quite a bit, okay? The median is your middle number, right? Okay? The median in this data set was 96. If I then include 6 numbers, my median or my middle number switches to right in between these two, And when you have two middle numbers, you take the average of those two middle numbers, and the average of 96 and 96 is still 96, okay? The median, in this case, did not change at all. It might change, but it's only going to shift from one number to the other. So it is more resistant. It's not completely 100% resistant. It is way more resistant than a mean. So it's more resistant to an outlier, only has little change, if at all. Right? It's only going to slide from one number, like one number or another. So not very much change. All right, mode. Change. All right, let me erase some of this stuff here because I've got a mess now. Okay. All right, mode. What was the mode in this data set? 96, right? And mode before I throw the 0 in is there is a 96. If I add the 0 in there, what's the number that occurs the most? Still 96. It is very resistant. Yes, resistant. And some of you guys are going to say, well, that's not necessarily true. What if you have two zeros in there? Then 0 is no longer an outlier because there's two of them, right? It's only considered an outlier if there's only one of that value, right? That's an extreme value, okay? So a mode is very resistant to outlying values because it's not going to change. Okay, and then range. Before, my range, highest minus lowest, was 90 minus 95. So I had 4 for a range of values. Now my range is 99. Huge, huge change. Probably the most change. Changes the most. It changes more than the average does, right? So it is the least resistant to outliers. The range will have the absolute most change, okay? We'll talk about mid-range. Mid-range is going to operate kind of like range does. It's not going to be very it's going to be, well, no, that's not true. That's not true. We'll talk about mid-range when we get there, okay? Mid-range is like on this backside here. So anyway, so as far as it gets to resistant, that's probably a different term than you've maybe ever heard before. We kind of know what mean, median, mode, range are, but when it comes to resistance to outliers, that's kind of what we're focused on, all right? Let me go up here. Important properties of the mean. Sample means drawn from the same population tend to vary less than other measures of center. Okay, so let's talk about this. Sample means drawn from the same population, okay? So let's say I am sampling and I am having you guys take a test, a stats test, okay? Versus, let's say, all seniors taking a stats test. You guys are going to all have similar grades on that stats test just because you've been exposed to the same information. Versus everybody else is, you know, you might have somebody score really high, but you're probably going to have some people score really low because they're not exposed to the same information, right? So sample means drawn from the same population tend to have less variation, right? They're going to be about the same than other measures of center, all right? The mean of a data set uses every data value. Interesting. Okay, so let's talk about that. The mean uses every data value because you're adding all of them up together. The median does kind of use every data value, but it doesn't really matter what those values are, right? If I had a set that was 1 and 2 and 3 and 4 and 5 and 6 and 7, and I took the median would be 4, right? Versus what if I had a data set that was 1, 1, 1, 4, 7, 7, 7. What's the median there? Still that number. So it doesn't really, a median doesn't really take into consideration every data value, right? Like, I mean, it's just making sure that that number is in the middle, right? Mode. It doesn't really take into consideration every data value. I only care about the one that shows up the most. I don't care what the other values are. And then the range does not take, the range, you only look at two numbers, right? It doesn't matter what the middle numbers are. So mean is the only one that takes every single data value into consideration, okay? That's why when we do grades, right, we want to use the mean because we're taking every single homework assignment into consideration. That's why we don't do a median or a mode. It'd be nice if we did a mode. All I'd have to do is get 200% and then every other grade could be in the 20s as long as it wasn't 220s, right? So anyway, all right, disadvantage of the mean is that just one extreme value can change the value of the mean substantially. So the mean is not resistant, okay? All right, let's talk about some of these variables. We will see these variables like every single day from here on out. All right, so the sooner you learn these variables, the easier life will be for you. So this little guy is something called a Riemann sum. He's a summation, and it just means you're taking the sum, okay? So this is how they denote finding a mean. It is the sum of all of the x values, which are all of the data values, divided by n, and n is the number of data values, okay? So the sum of all x's, the sum of all the numbers, divided by n, okay? X is the variable that is used to represent the individual data values. N is the number in your sample. I'm going to say number in the sample. Capital N is the number in your population. That's what capital N is, okay? So this sum of all of the x's divided by n, how many people were in your sample, we call that x bar. And that is another way of saying the mean. So we have just found the first variable substitute or symbol that we will use for mean or for anything. X bar is what we use to refer to as mean, okay? Now, this guy right here, this is the sum of all of the x values divided by the number in the population, okay? When we divide that, we don't really do this too often because most of the time we don't know how many people are in the population, hence the reason why we're doing a sample, right? But let's say we did. He is going to give us mu, which is kind of like a mean, but it is for the population. And this guy's name is mu. Mu. It's kind of like an M and a U at the same time. It is called mu. It's a Greek symbol, by the way. But it's called mu, and it's the population mean, okay? So a lot of times what we do is, since we don't know anything about the population, we use our sample mean, which is x bar, and we say, okay, we don't know what our population mean would be, but we know our sample mean is this number, so we can use that to estimate that probably would be close to what the population mean, as long as we had a good sample without bias or voluntary samples or anything crazy weird, okay? I'm kind of going on a rant here. All right, so remember these variables here. You're going to see those a lot. All right, let's do something easy. Mean. We have this many numbers. Oh, gosh, and I have to get a calculator out. Does it matter if they're in order or not, if I'm doing a mean? No, it doesn't. You can add them up in any order, whatever. And I'm going to add them up, and I'm going to divide by 5. So, hold on. Give me a second. I'm old and I'm on my phone calculator, so. And if I type a number in wrong, I'm going to be so sad. I don't think I did. I think I did it. 153.7. I hope that's right. Anyway, divide by 5. Let's see if that seems reasonable. Ooh, does that seem reasonable? 30.74. I don't know. Yeah, it does, because I've got a 55 and a 38. Those are going to pull the average up. So 30.74 sounds good, except the rule. And we're going to go down to this. Let's see, where's my rules? My rules. On the second page, the rounding rules for mean, median, and mid-range carry one more decimal place than is present in the original set of values. So I know I'm going to piss a bunch of people off because they're like, that's not the right number of sig figs. Okay, be quiet. We're not going off of sig figs. These each have one decimal place. So the rule is you carry one more decimal place. Okay, and I understand that that's not the way sig figs operate, but whatever. That's what we're going to do. Okay. All right. Median. Important properties of the median. The median does not change by large amounts when we include an outlier. So it is a resistant measure of center. It is way more resistant than what the mean is. Okay. The median does not directly use every data value. For this example that I gave up here. 4 is the median in both of those data sets. So it did not matter that I changed those data sets at all. because 4 is still the median. It does not directly use every data value, okay? All right, let's do 2 different medians, all right? We have an odd number of data values, so here I have 5 numbers, 5, and here I have 6 numbers. They've added in another one, all right? So I'm just gonna go in order. I've got, I'm gonna put it over here, 14.1. This is the tedious part. I've got to put them all in order. And you guys can probably, because there's only 5 numbers in this data set, you can probably like find the median without even putting them in order because you're just good like that, I guess, or something. I don't know. Okay, so some of you guys do this. Cross, 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 cross. I don't do it that way. Okay, and I'll show you how I do it here in a second. This is the median. 23.1 is what the median will be if I have 5 numbers, okay? If I, let me go back. Okay, if I add a value in there, like in this one, example 3, I'm adding in a 24.5 right here. 24.5, he goes there. So now my middle number is in between these 2 numbers because I have 6 data values. So how do I do that if I'm in between 2 numbers? Oh no, gosh, what am I doing? 24 doesn't go there. 24 goes there, but it doesn't matter. I'm still going to be finding the median between these 2, right? So when I have 2 middle numbers, I'm going to take the average of those. So you take 23.1 plus 24.5, and I divide by 2, okay? 23.1 plus 24.5 divided by 2. I could have done that in my head. I don't know why I did that. 23.8, that is the median now. Okay, even though 23.8 isn't even a data value in here, we take the average of the 2, right? It doesn't matter because we don't have an exact middle number. All right, now let's say you have 53 numbers, right? Okay, and I have 53 numbers going across here, and it drives me absolutely insane because I have kids that like cross, 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 cross. Now I've lost track of my crosses, and I can't find the middle to save my life, and it's terrible, okay? So don't do it that way. Do it this way, okay? If I take 53, since it's an odd number of numbers, I am going to have an exact middle number, so I'm going to do that, right? If I have 53 and I divide that number by 2, that would be 26 over here and 26 over here, because that would make 52, right? And then I have 1 number in between those 2, and that number is going to be the 27th number from either side. So now, rather than cross, 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 I count from either the front or the back. It doesn't matter which way you count. You're going to count, and it's going to be the 27th number, okay? Same thing if I have, like, let's say 24 numbers, right? Okay, I don't want to cross, 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 cross. If I have 24 numbers, 24 is an even number, so I'm not going to have an exact middle. There's not going to be an exact middle. I'm going to have 12 numbers over here, and I'm going to have 12 numbers over here. These numbers over here are the numbers the first through the 12th number, not necessarily numbers 1 through 12, but the first through the 12th number. These numbers over here are going to be the 13th through the 24th number, right? So I'm going to take the average of the 12th and 13th number in the set, right? Not necessarily in the numbers 12 and 13, right? But the 12th and the 13th number, I'm going to average those together, okay? So don't do this cross, 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 cross crap, okay? You can if it's a small data like set, like if there's only 6 numbers. But 53 numbers, I am not going to cross, 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 okay? So don't do that. All right. How long have I been talking for? I don't know. Let's talk mode quick, and then we'll be done. Okay, the mode can be found with qualitative data. A data set can have no mode, or 1 mode, or multiple modes, right? If it has 3 numbers that appear 4 times, each of those 3 numbers is going to be a mode. Like you're going to have 3 modes. A data set can have 1 mode, more than 1 mode, or no mode. I just said that again. When 2 data values occur at this greatest frequency, each one is considered a mode and is called bimodal. That's 2 modes. When it has more than 2 data values that occur with the same frequency, it's called multimodal. When no data value is repeated, we say that there is no mode. And when you have ice cream with your pie, it's called a la mode. Ha 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 ha. Okay, you're not laughing. Anyway, example 4. What is the mode? Do these have to be in order to like find a mode? No, not necessarily. It's easier to see if you have them in order. Now, question. 0.3 appears 3 times and 0.6 appears twice. So are they both modes because they both appear more than once? Or is it just 0.3? You only go with the one that occurs with the greatest frequency, not just because it occurs more than once, right? So my mode is 0.3. There you go. All right, I've talked enough. You can start going and doing some of these homework problems. And you can't do mid-range yet, but you could do like ABC, right? Median mode. And you can do 2 and 4 and 5 and 6. I guess you could do all of these in 22. Yeah, let's do that. Yep, let's do that. Do the first page, okay? Except for mid-range on 5 and 6, all right? You should be able to do the rest of those, okay? Happy Friday. Have a good day.